CertManager today. Okay, this is quite important. It will give you almost a production like experience. Okay, after implementing CertManager, what is CertManager and all I'll explain. But this in this exercise we also need to do yesterday's exercise again. So every day I delete the cluster and create it again. Okay, so before the class my cluster is ready. I've started. So it takes almost 15 minutes to create a new EKS cluster. I deleted it yesterday and installed it again. So Ingress will have to install again. So with Ingress we can have routing rules for websites. Okay, so that's what the ingress is used for. That means using a single load balancer we can access multiple websites. Okay, so let's start with it. So we'll have to make sure we have Helm installed. Okay, we'll be using Helm, okay, to install a ingress. So I'll install Helm using this script. Okay, so helm.sh, maybe I already have. Yes, so I can directly run it. Helm install.sh bash helm install.sh. So this will install Helm. Helm is a kind of a package manager for Kubernetes, the way we have it for uh, Linux operating system, apt-get or yum and all. Similarly, we have Helm for Kubernetes. That's the easiest way to understand Helm. So using Helm, we will install ingress. Okay, and most of the Helm charts. So actually, Helm contains various manifests. Okay, so it means pre-configured or pre-made a manifest. Okay, and this artifact hub has all the Helm charts created by others and shared with uh, everyone, so we can access it. It is like the GitHub of the code. It is only for Helm charts, and if you click on install, it will have to install this repository and install the chat. The same is given in the document as well. So we'll just install this repository. Okay, okay. We are having the same VM. Okay, everyday VM is same, so it is already installed the repository. Okay, so next we just need to install the ingress. So yesterday the name was only ingress nginx. Today it is my ingress nginx, but not an issue. It is just a name. Okay, so the ingress is installed. When the ingress is installed, we can see using Helm ls. Okay, but again, like yesterday, we made a mistake that it should not be installed in the default namespace. Okay, but still, what we will do is we'll just uninstall it. So the command would be uninstall my ingress nginx. Okay, so this will uninstall it. Let's check it using Helm command. So with Helm repo ls, we can check what are the charts we have. So we have two charts. Okay, so this is what we are interested in. This one I use for some other purpose. Okay, so this is the ingress repository we already have. Using this ingress repository, we can install ingress Helm charts, and we have to install it in the ---- namespace. Same name will give ingress nginx. We'll create a new namespace with this, and as this namespace is already in, it's not present already, so we'll just use create namespace. Create -namespace. So it will create a namespace, and inside that namespace it will install the ingress. Okay, the ingress is installed. Let's cross check with this command Helm ls. Okay, and Helm ls will show the details of default namespace. So we need the details of ingress nginx. So this was the namespace we used. So now we can see that the Helm chart is installed, and we can also see that it has created a new namespace, get namespace ns, and we can get the details of all the pod services and all inside the ingress namespace. Okay, we can see the ingress is installed. Okay, it has a service, so by default it will create one load balancer. It will get a load balancer from AWS itself because we are on AWS. So in AWS it is very easy to create ingress, and we have a load balancer now. So how it will work? So the request will come on this load balancer. Okay, this one, which is created by ingress. So ingress manage load balancer. Then we have ingress rules. Some rules will be creating that whenever a website, this website comes, forward it to this service. If the request comes to this website, forward it to this. So similar rules will be creating now. In short, we'll be creating two pods or two services. One will be app1.exa particular domain name.com and app2 dot particular domain name.com, and with those routing rules it will automatically redirect the traffic to a particular service. Okay, but this yesterday whatever we saw it on example.com domain. Okay, today we'll see it on a particular domain which we registered last time. Okay, so I registered this demolabs.in.net, so that I will use for the demo, and on top of it we'll be installing certificates on it. Okay, so after creating the ingress, we also need to install certificates on it. So certificates are nothing but the SSL. So if you see it here, it is saying connection is secure. Okay, certificate is valid. Okay, but yesterday when we created, it was for a private domain. Okay, which was not resolvable. So we'll have to use a domain which will have a proper DNS, which will resolve properly, and we'll also have a certificate for it, valid certificate. So like ingress is for routing traffic and all. So we have a controller called CertManager, okay, which is also an open source, okay, mostly created and used in Kubernetes. We'll install the CertManager the way we did ingress. Okay, and what does the CertManager do? It will automatically assign the certificates. Okay, and by default it will assign a certificate from a let's encrypt. Okay, so let's encrypt. Okay, it is the company which provides, okay, free certificates only for 3 months. After 3 months we'll have to renew it. Okay, so it is very famous. Okay, and many people use it, but the major advantage of using certbot is after every 3 months the certificate will be expiring, and then in generally we'll have to manually renew it. Okay, but certbot will take care of it. It will automatically renew the certificate. Okay, and various other use cases are also there, but this one is important one. And how it works. Okay, so whenever everything is automated, so automatically a request will be sent, okay, to obtain a certificate. Okay, and for that it needs to do some verification. So some verification, if we have to do manually, we'll have to use two methods. One is HTTP. We'll have to add one file in our website, and it will automatically check if that file exists, and that file is also given by CertManager, let's encrypt itself. And another way is we'll have to create a record and all, and it will verify whether the given record by them is we have added it properly or not. This is the manual method, but this also it will do automatically. It will use by default HTTP. It will create some file automatically. It will get it verified. So all these things, the CertManager does it very well. Okay, and there are some commands, okay, to get the certificate details and all, listing the issuers and all. So what are issuers and all, we'll see next. Okay. So this theory is important, and the commands are also useful in the production environment. So now we have installed Ingress. We have a proper load balancer IP. So host. Okay. So yesterday also we saw that the load balancer at the backend has two IP addresses, public IP addresses, which they use for high availability and all. So we'll be using this load balancer name, or you can say this is a alias. Okay, so we'll have to use this to point it to the website which we'll be creating. Okay, so indirectly the ingress rule will redirect it to this load balancer, and load balancer means actually the request will go to this load balancer. The load balancer will see whether there are will forward the request to an ingress, and ingress will check if there is an entry for that particular website or not, and where it should route the traffic. Okay, so that's why we'll have to map this load balancer to particular website name in DNS. Okay, so it takes some time, so let's first do that. I'll just log in here to my Big Rock account where I have this domain. Okay, when you open the page, you will get this domain page. In that, click on DNS records. Okay, and we have to add a CNAME. CNAME means adding an alias. So for which domain we need? So I think it is web app 1. Let's confirm it. So we'll go to this lab ingress and cert manager, and okay, so we have to add web app 1. Okay, so in example we have given this, but this is for now the load balancer is changed, so you'll have to check your load balancer and add such entry. So go to DNS record, go to CNAME. Okay, we'll add a subdomain. So we do not need to add full domain name. Okay, just give subdomain, that is web app 1. Okay, and where we need to point it, we need to point it to this load balancer. Okay, we can also create an A record, but at the backend it has two IP addresses. So let's create an alias. Alias means whatever request comes to this, it will go here. And let's add one more record. The first one is, if you see, it is done. Now let's add web app 2 as well, and the same name, this. Okay, so maybe at least 5 minutes I use the same name. I'll have to use web app 2 and save records. So we have two entries, web app 1 and web app 2. Whether it's resolving properly, DNS propagation is done or not, we'll check after some time. So this is done. So what we have done, we have installed ingress. Okay, we added two records. Okay, two DNS records. One is for web app 1 and other one is for web app 2. So steps are given for DNS for Big Rock. Okay, this is one of the registrar, domain registrar. If you have domain from some other provider, then the steps may vary, but mostly we'll have to make an entry of CNAME there. Now it is done. We're using this command, we can check it, but we'll check after installing the cert manager. So again, we can use the same website. Okay, the artifact hub. Okay, here we have details of how to install the cert manager. So we are using the same, okay, commands, but in our separate namespace. Again, we'll create a separate namespace for cert manager. So let's follow the documentation, and this is the first command I'm running. So we are on our Kubernetes cluster, kubectl get all. We have the two nodes, kubectl get nodes. we can get more details of it of using -o wide. Okay, we have two nodes, Amazon Linux nodes, just to help repo ls. So we already have ingress and one another repository. Now we are adding one more, jetstack. Okay, so jetstack repository maintains CertManager related updates and all. So we have a jetstack. Now the repo is added. Now let's install the Helm chart for CertManager. Okay, so just copy paste as it is. So we are installing a CertManager. We are creating a namespace CertManager. Okay, and just enter. So the command is taken from here only. Okay, this only we have added namespace into it. So our installation is done. Okay, we can cross check it using helm ls command. Okay, but helm ls will not give any details, so we need to check it in a particular namespace. kubectl get namespace helm ls -n CertManager. So we need to make sure that uh, the helm chart is installed or not. The charted installed, and we also need to check now if all the pods related to the cert manager running or not. So go to the cert manager namespace and do get all. We should see all the pods and services running. Okay, so everything is in running, nothing is in failed state. That means our installation is successful. Now we can proceed further. Okay, so this is done. Now we need to first check. Let's check this whether the DNS propagation is working or not. So one of the command is host command. Okay, okay, so it is properly pointing to the load balancer. Okay, similarly, let's check for web app 2. Okay, we can also check using ns lookup web app 2, also for web app 1. Okay, so there are various methods. We can also check this whether the propagation is done across all the DNS server all over the world using some websites as well. Last time also we have seen. So let's do DNS propagation checker. Okay, so what is my DNS.net? Just paste it here, and which record we need to check whether the CNAME is propagated properly or not. So if you see on most of the website on the servers, it is done. That means it will work properly. Now the DNS propagation is done. We need to create manifests for the two applications. Okay, so first we installed Ingress, then we installed CertManager on a EKS cluster. Now we need to add a cluster issuer as well. So what does that cluster issuer means? It means which provider we are using for getting the certificates. Okay, so the cert manager is not the only provider, or let's encrypt actually is not the only provider. There are various certification providers. So certificate SSL certificate providers. So there are very cheap SSL certificate given by Namecheap. Okay, then HostGator. Most of the websites, many people are giving SSLs. Okay, so we can use Komodo is one of them. DigiCert. We can take it from anywhere. Okay, and according to that, this definition will vary. Okay, so here we are saying we are using cluster issuer as let's encrypt. Okay, prod. So they also give for testing staging. Okay, instead of prod we can also use staging, because sometimes we need to make sure that the configuration is done properly or not. Okay, then we should go for prod. So the let's encrypt staging one will be giving a fake certificate only for testing purpose. Okay, and then we can, after testing, we can go for prod. But in this case I know the configuration is correct, so I'm directly using the prod one, prod cluster issuer. So this is mandatory, otherwise we'll not come to know why the certificates are not being assigned. So we'll create this file, cluster issuer. So in our case the cluster issuer is let's encrypt prod, not the staging one. So if you see, here we are defining two things. First, the cluster issuer is let's encrypt, okay, prod. So for verification, sometimes it may use it, but I'm saying that my email address I have given, and here I'm saying that it will be used in a ingress. Okay, so ingress is not the only what we can say provider. Ingress, Nginx is not the only ingress. There are various other ingress also in the market, because Nginx is very famous and popular, that's why we are using it. But here it can be Istio, Kong, there are various others as well. So that time we can define it here. So if you see, it says Acme part is always used for verification. It will provide us the certificate, but it needs to verify. So how it will verify? It will use email address, but though no emails are sent initially, okay, it will use HTTP Acme. So if you remember, here I explained Cert Manager, that how Cert Manager works. Okay, here the DNS challenges are checked to prove donor ownership, okay, using DNS TXT or specific file or HTTP. So when we say the controller use HTTP method, it will automatically create one file, and that file will be verified by let's encrypt. So it is done automatically. We just need to define what needs to be used. Now just kubectl apply -f cluster issuer. So that I forgot one line again. So I'll just add that line. Let's create a new file again. So this line I missed, first one. And if you see, it is getting created in CertManager namespace. Here we have defined already inside it namespace. But if you do kubectl get cluster issuer, it will say let's encrypt ready true. If you get it here false, that means something is wrong. Okay, you should always get true here. And here, even though it's installed in Cert Manager, from everywhere will get the details of cluster issuer. So as the name suggests, it will be available for the whole cluster, but it is also possible to get it only for a specific namespace as well. Okay, but here we are using the same for whole cluster itself. Okay, so what we need to do, we need to install it for the whole cluster, and when we say kubectl get cluster issuer, it will show true. So we don't need to go to any particular namespace and check for cluster issuer. It is available for the whole cluster, but it is also possible to have only for particular namespace using issuer. Instead of cluster issuer, it will be issuer. Now we need to create the configuration files. Okay, so first one will be web app 1. For web app 1, we'll create deployment, service, and ingress. In ingress itself, we'll say that we need a SSL certificate. So This is first part is deployment, this is service, and this is ingress. I'll explain it. And if you see at the last, we have saying TLS. Okay, that means for SSL certificate, use this configuration. So we'll create two replicas for HTTPD image. Okay, and it will run on a cluster IP port 80. Then we are saying an ingress. We are creating an ingress. Okay, and the name of the ingress is web app 1 ingress. Okay, we can give short name as well, and we are saying that create a website web app 1 ingress. That means here we are defining the rules that whenever the request comes for web app 1, okay, forward it to the service we have created here, and this service will automatically forward it to the pod. Okay, and here we are defining get a SSL certificate as well. So SSL certificate also creates one secret automatically. So that's why we are giving it a name as well, secret. So just a small configuration for TLS. In the existing ingress, just add this, that this will be the name for the certificate. This will be the secret we need to create. Okay. Similarly, we'll create one more file. Actually, no, it's okay. We can create only one example. Okay, the second one is also given. Let's do that as well. So I'll create one more. Cat web app 1 and then now web app 2. Now let's apply both, but at a time we'll apply one. Then we'll take the next kubectl apply -f web app 1. So what was the name? Yeah, web app 1. So let's check that kubectl get all. We have created everything in a default namespace. Okay. So if you see, it created, we will not get to see this always. Okay, so it created one pod which does the verification at the backend. It is doing the verification for us. It created a file and it is now verifying it with the let's encrypt. Now it will not show. That ran temporarily and it died. Okay, now these two pods are created using this deployment. We have this service, okay, which is on cluster IP. It's not exposed to everyone. And now we can see the ingress. Ingress will expose it to the outside world via load balancer. So if you see, web app 1 is created, okay, ingress, and it is saying that it's available on this load balancer IP. Now we can check this. So one of the command would be curl webapp1.net. Okay, so if you see, it is saying permanent redirect because it redirects HTTP to HTTPS, and on website on curl it will not give the output properly. So we'll have to write HTTPS : and now it says it works. Okay, so let's check on our browser as well, webapp1.example.com. So if you see, we have a valid certificate here. Connection is secure. Certificate is valid. We can get more details of this certificate. Okay, so it is created for web app 1. Okay, it's given by let's encrypt. Okay, when it was created and when it will expire. So it will expire on 18 September. That is after 3 months. Okay, so if you see, we have done it very easily. If you do it in a production on a VM, it will take a lot of time, okay, if you do it manually, but due to the cert manager it's very easy. So similarly, let's apply web app 2 as well, configuration for web app 2. And if you see, ingress is there, okay, it's creating. So let's till then check if it has created the pods or not, pods and services. So again, if you see, it is doing the verification. So we have this pod. So the second deployment is done. The two pods are for that deployment. So the configuration is done. Let's check the ingress as well. So we have one more ingress. Okay. So it's taking time. It will point it to the load balancer. Just wait for it. So we can also describe the ingress. If there are any issues, it will show it in the describe. Describe ingress will describe both. Okay, if we have to select a particular ingress, then we can also describe that particular ingress, that is this one. So always make an habit to get details using describe, because when you have some error, it will show it somewhere that whether it is successful or not. So if you see, it has successfully created certificate. And when you if you do mistakes, okay, and if you try to get this certificate again and again, okay, at the back end, there is a limit, okay. So sometimes it will stop giving you certificates if there are some errors, then you'll have to try it next day. So this was done. Now let's check with curl command, web app 2. Don't forget to add https. So it says it works. The same we can check it on the browser as well. So it works, and if you see, it also has a valid certificate.